Alright, let's walk through the difference between changing the display coordinate system and permanently changing the coordinate system assigned to a data set. This states outline data set is in a geographic coordinate system. You can see that from the stretch. And then it shows here that the units are degrees. The extent values are all very small, meaning that they're angles. They're all less than 180. And the geographic coordinate system is listed here, nat 83. So I can change the display coordinate system by going into layers and properties and going up to the projected folder and picking something. Say we want to work in the lower 48, so I'm going to pick a US contiguous. We're not working in Alaska, so I'm going to work on something that works in the lower 48. Okay, so here's the data projected on the fly. I haven't actually affected this data set. If I look at the data set itself, it's still in a geographic coordinate system. I'm displaying it using a projection. Typically this is how I leave data, because every time you project the data to change the PRJ file that's associated with this data set, you erode the accuracy a little bit. And what I mean by that, let me bring up the view in Windows. Hang on. So this is the data that's displayed in the map. It came from this folder here, USA folder. So the state P010 consists of all these data here with the different file extensions, SHX, SHP. So these are because it's displayed in ARC right now. But this PRJ file is the projection file or the coordinate system file that goes along with the data set. If I were to delete this, this data would say that it is undefined. The coordinate system is undefined for this data set, and we'd have to fix that. So this is what I mean by permanently changing it, is that we would overwrite this PRJ file. So let's do that. If I searched for project, you're going to see some different choices here. You can project rasters, you can define projections on rasters and vectors. So defining it would overwrite the existing file entirely and assign it a new coordinate system, and that wouldn't work because the extent values, the coordinates associated with this, are going to remain 71, 17, 179, etc. It doesn't change the extent values, it only changes the units and the origin for the data set. So if we were to overwrite that using the define projection, it's going to completely wipe it out and say, all right, we're going to plot it up in, let's say, US contiguous, equidistant, conic, and wherever that coordinate system's origins are for the X and Y, it's going to plot it up 179 meters to the east, 71 meters to the north, and what's going to happen is your data is going to plot up as a tiny little dot, basically, because it's going to be very, very small. So instead of the extent being defined in degrees, which are big on the surface of the Earth, the arc of it, it's going to plot up meters on the surface. So that wouldn't work for the continental US. So we're going to use the project tool, and what the project tool does is does a mathematical transformation from the existing coordinate system into a new one, and that's what we want to do. We want to recalculate the actual extent values. So I can put in that guy. It should automatically populate with the known coordinate system of it. I'm going to just let it drop in here because I'm going to delete it anyway, and then I'm going to tell it that I want it to be transformed into the US contiguous, equidistant, conic, because that's what's going to be appropriate for my analyses. You don't have to put in a geographic transformation. ARC knows how to do that. Now, are we going to see any change to this one? We were told to put in an output file name, so I would not expect this to change, but this will have the new coordinate system. So this guy hasn't been affected. It still is in a geographic coordinate system, but our new one has a projected coordinate system, US contiguous, equidistant, conic. It displays on top of the other data because it was mathematically transformed correctly. Look at the extent values. They've changed to really big numbers because mathematically they were transformed from angles into Cartesian XY coordinates. So I hope that makes sense.